Hey everybody, welcome back to day 5 of summer school geometry. In this module, we're going to be talking about special segments in triangles, as well as applying the midpoint and distance formulas. So we'll talk about these three things in here: special segments, the midpoint formula, and the distance formulas. So we'll first start by identifying what are all these different examples of special segments in any kind of triangle. So I've drawn, or I have 4 different triangles up here, and there's these 4 different terms. There are 4 different types of segments inside of a triangle. So the first thing we have is called a perpendicular bisector. So the first thing that's important to remember is a bisector cuts something in half. So what I'm going to do here on this triangle is I'm going to take the bottom side of the triangle, and I'm going to mark the midpoint, the halfway point of that side. So I'll just denote that these 2 little pieces right here are the same size. So this middle point right here is halfway through. So this point is the bisector. It's halfway. Bisect means to cut in half. And perpendicular means to create a right angle. So I'm going to draw a line that's going out of that point at a right angle. So this is called a perpendicular bisector because it's perpendicular to this side and it cuts it in half. It cuts the bottom side of the triangle into 2 equal parts. That's what a perpendicular bisector is. Then we have a midsegment. A midsegment connects the 2 midpoints of 2 sides of a triangle. So if I draw the midpoints halfway in between 2 of the sides, so I'm going to mark these 2 segments are equal to each other, so that means this is halfway. And then same thing over here. We have 2 equal segments on this side. So the mid segment would connect those 2 midpoints like that. The next thing we have is called an angle bisector. An angle bisector is very similar to a perpendicular bisector. It cuts something in half, but it cuts an angle in half. So what I'm going to do is I'm going to draw this angle right here, and I'm going to mark the middle halfway point of that angle. So the 2 angles on either side that are formed should be equal to each other. So now I'm going to just draw a line that goes through there. So now if I look closely, this angle and this angle on either side are 2 equal angles. And this line, it doesn't end up at the midpoint of the opposite side. It just ends up at any random point, but it has to be right here that it's cutting this angle in half. That's an angle bisector. And then the last thing is called a median. A median, you'd go from the midpoint of a side to the vertex of the opposite side. Just like that. It's a straight line that goes from the midpoint here all the way across the other side. That's called a median. And so we can use these special segments in different ways. They have different characteristics that we can use. Okay, so earlier I talked about a midpoint, and we'll go over what the midpoint formula is now, as well as what the distance formula is. So if I had a straight line and I had point A and point B, just like that, and I wanted to figure out what's halfway in between there. And I'm given coordinates x1, y1, x2, and y2. It's going to be a coordinate x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. And so this should end up being a number, and this should end up being a number, which gives us another coordinate in between these 2 first original coordinates. And then the distance formula tells us how far away 2 points are from each other. So the distance formula, I'll mark in red, is the length of the line. And the way we find that is the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, just like that. So in your assignment for today, you'll see some examples that are similar to this where you'll have to find the midpoint. So let's find the midpoint of the segment with these two endpoints. So let's say this is point A and point B. And just real quick, I'm going to sketch where these coordinates are approximately. We want to figure out what's the halfway mark. So the halfway mark, what we need to do here is just use the midpoint formula we just talked about. The midpoint formula. So now what I need to do is I need to come up here and think about what's x1 and x2. Remember, the first number is always the x value. So 10 plus 2. So I'm going to erase this and put 10 plus 2. Then I have y1 plus y2. y1 and y2, that's 3 and 9. So I got 3 plus 9. So now I just do the math here and I simplify this. 12 divided by 2 is 6. And then over here, 9 plus 3 is also 12 divided by 2 is equal to 6. So in this problem, we ended up getting 6, 6, but that doesn't mean that every problem will end up being the same two numbers. It just depends on what the two coordinates are. And so there's the midpoint formula. Now let's talk about the distance formula. Here we have two other coordinates. It says find the distance in between the 2 points. Now the distance is a different formula, which we talked about at the top. So this is x1, y1. This is x2, y2. So now what we want to do is we want to find the distance between them. Now the distance formula, all right, so what we want to do now is just go in and fill in these coordinates right here. So first let's figure out what's x2. x2 is right here, it's -5. So I'm going to erase x2 and put in -5. The minus is going to stay right there, but I need to replace the x1. x1 is +4, so I'm going to erase x1 and put in the 4. So I have -5 minus 4, that thing squared. Then I have plus y2 minus y1 squared. So I'll just go in and replace each of these. y2 is 3. y1 is -9. So there's already a minus in the formula, and this is a -9. So if this ends up being a negative number here, then I'm going to put -9 again in there, minus a -9. So this indicates to me that I should add these two. Minus a negative, two negatives make a positive, so I'm going to add these two numbers up here. So now let me clean this up a little bit. And if I take the square root of 225, this is equal to 15, because 15 times 15 is equal to 225. So the length of the line between these two coordinates is going to be 15. Let's go over one last problem. Okay, this problem is saying, gives us this diagram right here. And it says N is a midpoint of KL. So this is the halfway point. So we know that those two are equal. P is a midpoint of LM. So these two guys are equal. All right, so that means that this is going to be just like this situation right here. This is a mid-segment. Okay, so NP is a mid-segment. It says if angle PNL, so here's PNL, so I'll mark that one. If angle PNL is 6x plus 63, And MKN is 78 minus 9x. So MKN, that angle, 78 minus 9x. Then I need to figure out what is the measure of MKN. So one thing to note about a mid-segment is that it forms something similar to what we've seen before. These are parallel lines. NP and KM are parallel to each other because NP is a mid-segment. So that gives me congruent corresponding angles. So these two have to be equal to each other. So now what I'm going to do is I'm going to set up an equation. X is equal to 1, but I need to figure out what's the measure of angle MKN. So I just put a 1 back into here. So 78 minus 9 times x, or 78 minus 9 times 1. So this equals 69 degrees. And that's the measure of angle MKN. Okay, so these three examples we just worked right here are very similar to the types of problems you'll see on your assignment for today. So go ahead and go back to Canvas, click on the module, and you'll see the assignment for today. As always, if you have questions, please send me an email. I'm happy to help and answer any questions that you might have. Just shoot me an email.